Okay, good morning everyone. So, this is the continuation of the report from Ma'am Marie. So, our subject for today is project quality management and the topic is Pareto analysis. Josefina P. Basquinia, the reporter. So, Pareto analysis is involves identifying the vital few contributors that account for the most quality problem in a system. Also called the 80-20 rule, so meaning that 80% of the problems are often due to the 20% of the causes. Pareto diagram are histograms that help identify and prioritize problem areas. Figure 7-2 sample of the Pareto diagram, which is the number of complaints this week. So, which is the log and problems. System locks up. System is too slow. System is too hard to use. Reports are inaccurate. So, this is the cumulative percent from the right side. Next is the statistical sampling and the standard deviation. Statistical sampling involves choosing part of a population of interest for inspection. The size of the sample depends on how representative you want the sample to be. Sample size formula. Sample size is 0.25 by open parenthesis certainty factor / acceptable error. So next is the table -2 commonly used certainty factors, which is desired certainly. So 95%, 90%, 80%. Next is the certainty factor is 1.960, 1.645, 1.281. So 95% is certainly is a sample size. So 0.25 times open parenthesis 1.960 times 0.5 to the power of 2 is equals to 384. 90% certainty is a sample size is equals to 0.25 times open parenthesis is 1.645 / 0.10 close parenthesis to the power of 2 is equals to 68. 80% certainty sample size is equals to 0.25 times open parenthesis 1.281 / 0.20 close parenthesis to the power of 2 is equals to 10. Standard deviation. So standard deviation is the measures how much variation exists in the distribution of data. So a small standard deviation means that data cluster closely around the middle of the distribution and there is a little variability among the data. So a number of distribution is a bell-shaped curve that is symmetrical about the mean or average the value of population. Next is the figure 7-2 is the normal distribution, which is the mean, so the normal curve. So 68.3% is the very low, so 95.5%, 99.7%, so which is the balancing of the below, that is what we call is the mean. So table 7-2 is the sigma and defective units, which is the specification range in plus or / sigmas. So also the percent of the population within the range and defective units per billion, which is number 1 is 68.27 is equivalent to 317,300,000. And the number 2 is 95.45, which is 45,400,000. Number 3 is 99.73, which is 2,700,000. Number 4 is 99.9937, which is 63,000. Number 5 is 99.999943, is equals to 57. Number 6 is 99.999998, which is the 2. So note that the Six sigma often refers to positive or negative 3 sigma, meaning the 2.7 million defects per billion units produced or 2.7 defects per million. Quality control chart 6 sigma and the 7 run RU rule. So a control chart is a graphical display of the data that illustrates the results of the process over the time. It helps prevents defects and allow you to determine whether a process is in control or out of control. Operating at a high sigma value like 6 sigma means the product tolerance or control limits have least variability. The 7-run rule states that if 7 data points in a row are all below the mean, above the mean, or increasing or decreasing, then the process needs to be examined for non-random problems. Figure 7-2 sample quality. So this is the time dimension that denotes violation of a run rule. Figure 7.5, so reducing defects with a 6 sigma, as shown the table. So lower control limit, upper control limit, the 2.7 million defects per billion, the 2 defects per billion. And next is the testing. Many IT professionals think of testing as a stage that comes near the end of IT product development. So testing should be done during almost every phase of the IT product development of life cycle. Okay, thank you for listening. Next reporter. God bless po.